Hello and welcome to lesson number 1 of Unit 0, Algebraic Tools in our grade 11 University College math class. This is a review of polynomials. So here we have an introduction to some of the terminology that we're going to be using when we're talking about polynomials. You may want to just pause this video right here and then fill this in or copy it down into your notebook. When you're done that, come on back and I'll talk you through this part before we get to the mathing. So I'll see you in a second. Okay, you're back. So polynomials, they refer to a number of terms in a collection of terms. We can identify when a term is over in that they're separated by addition and subtraction. So when you have terms, they have add or subtract in between them. That's the end of the first term and the beginning of the next. A little terminology: a monomial is one term, a binomial is two terms, a trinomial is three terms. Anything after that we just simply refer to as a polynomial, which means many. When we're talking about polynomials, they have two parts. They have the variable part, which is the part that has the letter, and we have the coefficient part, which is the number part. And we have a little example down here. We'll zoom in and have a little look at it. So here we have a trinomial, three terms, and you can see this because we're separated by minuses and pluses. So there's our first term, second term, third term. You can see in here that we have coefficients. Those are the number pieces. There's the 3, the 5, and this is a coefficient also, but if there's no variable, we just call it a constant, in that no matter what the variable is, that value is going to be the same. So a coefficient without a variable, we call a constant. Terms that have variables, we call them variable terms, and the variable itself is the letter. Exponents are the numbers that our variables, or I guess in some cases our coefficients, are raised to. It's sort of a little superscript number. We have one right there with the 2, and that's it. When you have a polynomial, you can simplify them by gathering together the terms that are alike. And we know that a term is alike when they have the same letters, which means the same variables, raised to the same exponents. So that's what the first thing we're going to tackle here is simplifying. It's gathering together like terms. So we have an example, A, and we have 2x squared plus 3x minus 4 minus x squared plus x plus 9. 6 terms in there. We're going to simplify this down to a fewer number, and that's what simplifying means. It takes sort of terms that are of the same type, and it combines them. And we combine them in the same way that we would add or subtract integers. So our first term, and I've underlined it in green, is 2x squared. Are there any other of the x squared type terms in there? There is. Minus 1x squared. And you'll notice that in my underlining here, I've included the sign as well, and that's important. The sign belongs to the term that comes after it. So we have a 2x squared minus x squared, and I've just done a rewrite right here of those two terms, and that's all the x squareds we have. Next I look to the x's, or the next term down the line. We have a 3x, so do we have any other terms that have a single x in them? We do, plus 1x, and I rewrite those two terms. And then the next term is a minus 4, that's a constant. Do we have any other constants? We do, it's a plus 9, and then I do a rewrite here. Now again, why am I doing this rewrite? It's lumping together or grouping together the terms that are alike, so simplifying them is easier. Is it a necessary step? Strictly speaking, it isn't, and when you get comfortable with it, you don't have to, but certainly in the notes I would encourage you to do it so that you remember how we did it. So then we are going to combine those first two terms that we rewrote. 2x squared minus 1x squared is 1x squared. Now if there's a 1 in front, you don't have to write it, but you can. Next we have plus 3x plus 1x. So that combines, we have 3, we add one more, we have 4 x's, and lastly we have minus 4 plus 9, that's 4 minuses, 9 pluses, together that gives us a plus 5. And that is how we simplify a polynomial expression. Let's do one together. Here we have plus 10x cubed minus 14x squared plus 3x minus 4x cubed plus 4x minus 6. Now this time I'm not really going to do any of the colorful stuff. I'm really just going to sort of group them together one at a time. So let's look at the beginning. Again, without seeing a sign in front, this is going to be a plus. So we have a plus 10x cubed. Are there any other x cubeds in this equation or in this expression? There are. Minus 4x cubed. So I'm going to do a rewrite right now. We have 10x cubed plus 4x cubed. So, all right, so we took care of those two guys. They're done. Next down the line, minus 14x squared. Do we have any other x squareds in here? We do not. So I'm just going to rewrite it all by itself. Minus 14x squared, that's been dealt with. Next we have a plus 3x. Any other x terms in here? There are plus 4. So a rewrite, plus 3x plus 4x. Those two guys are done. And then we have our constant term right there at the end all by itself. So now we're going to simplify the ones that are alike. So we have 10x cubed plus 4x cubed. That's going to be 14x cubed. The 14x squared was the only one, so we just rewrite it as it is. Plus 3x plus 4x is plus 7x, and there's our minus 6. So that is gathering together like terms, using sort of a rewriting step to group together the ones that are alike. Again, strictly speaking, that line right there, not necessary, but good for just making sure you minimize your mistakes. All right, so that's just adding a whole bunch of terms together, or I guess simplifying a whole bunch of terms together. If we're going to add a whole polynomial expression, so we're talking about adding this whole trinomial here, 4x squared minus 7x minus 5, we're going to add that whole thing to 2x squared minus x plus 3. What we do here is we have to basically remember that we are adding each and every one of these terms. And I'm going to do a rewrite step here. So this first one, there's a plus, an invisible plus in front of that 4. So plus 4x squared minus 7x minus 5. Now I'm going to add positive 2x squared. And I'm going to add negative x. And I'm going to add positive 3. So basically you can see it here. What I'm doing is this is the adding. I'm adding the first, second, and third terms in that trinomial. So we have sets of double signs now. So I'm going to do another rewrite here. I'm going to leave that plus off. I know it's there. There's our minus 5. Now two pluses, banging up, no number in between. We're going to replace that with a single positive. So plus 2x squared, a positive and a negative, banging up, no number in between. We're going to replace that with a negative, and two positives. We replace that with a single positive. And now, this is just like the example above. We're looking for any other x squared terms. We have one, there it is. So we have 4x squared plus 2x squared. Those two are done. We have a minus 7x and minus 1x. Minus 7x minus 1x. Those two guys are done. And we have a minus 5 and a plus 3. Those two guys are done. Alrighty. Now we simplify by gathering together the terms that are alike. We have 4x squared and 2x squared. That's going to give us 6x squared. We have minus 7x minus another 1x is minus 8x. And a minus 5 plus 3. Think of that if you like as 5 minuses and 3 pluses. There will be a net of minus 2. And there we go. That is how you add a polynomial expression. And again, this is important because what we're doing here is we're adding it. The next example we're going to look at is subtracting it. So how do we subtract an entire polynomial from an entire second polynomial? Again, it's the same idea here. We have to remember that we're subtracting every piece of this trinomial. So I'm going to rewrite my first step here, or my first grouping. That's a plus 4s squared plus 5st minus 7t squared. Okay, so now I'm subtracting plus 6s squared, and I'm subtracting plus 3st, and I'm subtracting negative 2t squared. What you're going to notice, again, so this negative, I'm subtracting the first, second, and third parts of that trinomial. What you're going to notice is that we have a whole bunch of double signs again. So let me just rewrite the beginning. 4s squared plus 5st minus 7t squared. Now here we have, let me change up my color here. We have a minus and a plus. We're going to replace that with a single minus, minus 6s squared. And we have a minus and a plus. We're going to replace that with a single minus, 3st. And we have two negatives, which we are going to replace with a positive 2t squared. At this point, again, just like the other examples that we did above, we have a 4s squared and we have a minus 6s squared. So let's do a rewrite. 4s squared minus 6s squared. Got those two. Plus 5st. There's that one. And minus 3st. Got those two. And a minus 7t squared plus 2t squared. Got those two. All right, and now we simplify. Plus 4s squared minus 6 is minus 2s squared. We have plus 5st minus 3st is plus 2st. And lastly, minus 7t squared plus 2t squared is minus 5t squared. Now, someone usually asks, if I wrote this in a different order, would it still be correct? And it would. You could also write this as 2st minus 5t squared minus 2s squared. Those are equal. Those are the same. As long as the signs stay with, as long as this minus or negative sticks with the minus 2s squared, and as long as that minus sticks with the 5t squared, it's exactly the same answer. I think most mathematicians would follow the alphabet and do s squared. A lot of times too, they would follow the order of degree, so that we would have the largest degree term first. In this case, minus 2s squared. Degree refers to the size of the exponent. So this is a degree 2 term. This is a degree 2 term. And this one, if you can imagine, this is s to the exponent 1, t to the exponent 1. Combined, that also gives us a degree 2 term. So the order here, unless you're really super strict about the letters, any order of this will work based on the degree. So that's the first part of this lesson. Again, I just put a little how to eliminate the double signs over here. If you want to, you can copy that down. This is the end of the first part. When you come back, we're going to talk about multiplying polynomials. So we'll see you in part 2.